We can see it.
Perfect. Okay, nice. Wow. Amazing. I didn't expect that it would work actually. Okay, great. So, hi everyone. My name is Robert, or R0bre. I'm the founder of Accretion, and I'm going to talk about Advanced Solana Bugs and some other things as well. This is going to be pretty much the same presentation I did for the first cohort, but I added some small tips at the end as well. So there's a bit of new content as well. Just briefly about myself. Been doing Solana audits now for 3.5 years. And been a security researcher in general before that. Like CTF, hardware hacking, and Spawn. I'm from Germany, and a super team Germany member, and I'm based in R0bre actually in the moment. And you might know me from my 100 days of Solana tips on X that I shared earlier this year. If you don't know about them, I think it's also a very good resource that you will also find on our blog of Accretion. Accretion is a security company, only 4 people at the moment. So we're kind of boutique, I would say, and we're 100% focused on Solana. So only Solana audits. And yeah, I mean, sometimes we post about some things about Solana security. So if you want to follow us, our handle is Accretion XYZ, as it's written here. So yeah, for today, I want to basically help you find some bugs that go beyond the Solana top 10 bugs, or I don't know who those are, but the most common bugs on Solana that you probably know now, or that you should know, are stuff that's listed here, like missing signer checks, missing ownership checks, and discriminator checks, account checks in general. Math issues like rounding bugs and over and underflows, and from Anchor, the remaining accounts is always error prone. Arbitrary CPI attacks, also very common bugs. Denial of service, for example, create account, or like init when you should use init if needed, for example. There's also a common bug, and state transition issues and logic bugs. They're a bit more difficult to find, more specific, but I think most people know about these type of issues, and like off by once, for example. Like these kind of issues, you should know, should be very familiar with those, and those are the bread and butter of auditors. And I'm not telling you to not look for those issues, but you should know those issues very well. But if you're a good auditor, you should go further than that. Because if you only find issues like this, like, you know, these types of bugs, that often can be done just by pattern matching. You don't really have to understand the code. Just for an example, the missing signer check, you can just see, oh, it's not checking a signer. Is it maybe important for this instruction to have a correct signer? You can see that almost immediately. And then it's a bug. Like, there's no deep thought process that goes into finding this issue. And that's the issue that will be something that maybe AI will be able to find, or already is. So if you want to stay in the auditing business, you should go further. Otherwise, you'll have to become a plumber. And yeah, auditing, I think, isn't about just pattern matching. You have to really understand the code deeply and the environment it runs in, and then find like a small crack in the bedrock of the code. And yeah, if you're doing that, then you can be successful even if AI becomes very good. So the idea for the further part is to that I will show you some code snippets, and the code snippets are like pseudocode. They're not exact real code. They're like AI generated shitty code that misses a lot of context, but I hope it gets the point of the bug across. And the bugs that I want you to find in those examples are not going to be missing signer check, missing ownership check, or something like that. So yeah, the idea is now take a look at those snippets. I'm going to give you maybe 1 minute per issue, per bug, and maybe you can like talk or post your ideas in the chat, and then we can find out what was the intended solution. Okay. So the first example is a market that has two accounts. One is like a market and one is a bet. It's like a betting market or prediction market, something like that. And a bet exists for one market. There can be many markets. Users can create new markets. Markets can be closed when they're resolved. And yeah, that's the basic structure. For example, will Donald Trump win the presidential election? And then someone can place a bet on that market, and it's like, I think yes, this market resulted true. And I'm betting 50 SOL. And yeah, that's the basic structure. Okay, does someone have already some idea? Cannot create bet more than one time. And yeah, in this, according to the seeds, you can only have one bet per bet or per market. But that's not the issue. Right, that market could be pointing to a closed market. Okay. Let's take that further. What do you have an idea what's next for that? Because that idea is correct. I I'm humming. Like the code will be buggy in the sense of it's written by AI and missing a lot of context. So it's like some formality doesn't exist in the code. It's not the intended bug necessarily. For closed market, you can assume like the market authority can close the market. Okay, so I don't know, a lot of good ideas. So the intended idea here is that of a dangling pointer. So 0x for Lifeman has had the correct idea. So you can have a bet that exists for a closed market. So you can create a market, place a bet on that market, and then close that market. Like the authority will close the market. But now the authority could create a new market and reopen it at the same address. So, for example, let's say we have a market that's like Trump wins, or will Trump win the presidential election? And someone bets, yes, I think Trump will win the presidential election, and it's quite likely maybe at the moment. And that market resolves, but the bet itself will not be resolved because maybe the user wasn't there or the crank didn't crank that user for whatever reason. The market gets resolved and closed. And then the authority can reopen a new market at the same address. For example, Ferrari wins F1 Constructors Championship or something like that, which is very unlikely. And then the existing bet, which was saying, I'm buying, and I think this market will resolve to true, will now be an existing bet for the new market, even though it was intended to be for the old market. So basically, when we close the market, an account that points to that market still exists and will be a dangling pointer, basically. And then we can recreate the market and undangle this pointer, which creates a situation where this user is having a bet position that they didn't want to have. One other example for this is token 22. So in token 22, you can have the closable mint extension, which allows a mint to be closed, the mint account to be closed, deleted by the mint authority, not by the close authority, basically, if the mint has a supply of 0. So all tokens have been burned. However, a mint supply of 0 does not mean that no token accounts exist for that mint. So you can have token accounts for that mint that have an amount of 0 in them, and then close that mint, and now you have token accounts for a mint that doesn't exist. And you could, at that address of that original mint, you could now create a different mint and you could even create like something completely different, like another token account. Now you have a token account that has a mint, or it's pointing to a mint, but it's actually another token account. and it's just, you know, rigged in some way. And that's a quite common bug pattern in Solana. If programs allow you to close accounts, you should check if this account that was closed can be recreated at the same address, and if there are some side effects that might exist from the previous account when it existed in the first place. So like other accounts that are pointing to this instance. Right, that's number one. For this bug, here we have like a program that takes a vote account from the Solana vote program as an input in the construct, and then saves the address of that vote account to a configuration account. And the check that is done on that vote account is only if that vote account belongs to the Solana vote program. There's no other checks. And the question is that check enough to ensure that we're saving a valid vote account to our configuration? Don't care about the signer checks. It's about the validity of the vote account. Okay, any more ideas? Otherwise, I'll explain it. Yeah, anyone can create a vote account for the Solana vote program, but that's not necessarily a bug. Like, I mean, that's kind of the intended, like being able to create a valid vote account. Okay, I'm gonna explain it. So the vote account is like an existing program on Solana, vote program. And the vote program only has one account type, which is the vote account. So if an account belongs to the vote program, I guess we could assume that it is of this vote account type. So we don't need a discriminator check. And we do need the account ownership check. So far so good. However, the problem is what we could do is we create a new account and we call assign, and assign it to the vote program. But we don't transfer any lamperts to that new account. So its lamperts will be 0. And that we do in the same transaction as calling this instruction. So our transaction will look like this. We have an account that belongs to the system program, has 0 lamperts. First instruction, assign this account to the vote program. Second instruction, call the vulnerable program set vote account instruction. So this instruction we're calling. And as a result of that, we will save this account in this configuration because the account belongs to the vote program correctly. We're not checking lamperts or anything. But as soon as this transaction ends, the runtime of Solana, of the SVM, will see, oh, this account has no data and it has no lamperts, and I don't care what program it belongs to. So what the runtime will do is we'll clean up the account, which means it will delete all the data from this account because it has 0 lamperts. Which in practice means it will reset the owner to the system. So in the end, what we end up with is we have this config account, which it thinks it's pointing to a vote account, but actually this was only a vote account for this one transaction. But actually it points to a system account now. And because it's a system account for which we are able to sign, we can assign this now to any other program and store any data in this account. And if this program now just uses this saved vote account in the future without checking again if this is a vote program account, and it's just, oh, we have it saved already, so we don't have to check it again, then we're going to run into a lot of bugs because of that. Question is, but when we create an account, the system program will assign lamperts, right? No. When we create an account, if you use the instruction create account, then the system program will do 3 things. It will assign that account to the program that you want to assign it to. It will allocate a certain amount of data, and it will transfer a certain amount of lamperts to that account. But only if you use the create account instruction. But you don't have to use that instruction. You can also just use the assign instruction and assign that account directly to the vote program without transferring lamperts and without allocating any data. And if that account has 0 lamperts, then it will stay in that state only until the end of the transaction. And at the end of the transaction, it will be cleaned up. Okay, so this is temporary program assignment. It's not really a common issue. Honestly, it's like we found it like once. And it only really happens like, I think, in like Pinocchio or like native programs. But it's still quite interesting, and you have to be aware of like how the runtime works and cleans up data. All right. So for the third bug, this is quite, it's actually quite simple. So let's imagine we have like a lending market that has a liquidation function. And this liquidation function can be used to liquidate a user if they are almost insolvent, or if they're insolvent. And for this, basically we do some health checks. So when someone calls liquidate for some other user, we'll have to check if that user is actually liquidatable. So we'll have to go to all their positions and see how they sum up and their obligations and how their obligations sum up. And if the total results in liquidation criterion. And yeah, we're doing it in this way here, and maybe you can have some ideas. Okay, I already see some responses. So previous one was, should that happen? What could an attacker do? What could happen to the protocol? So that question for the previous bug was, what could happen for this reassignment thing? So it basically depends what the protocol later does with that account. Because the developer will likely assume that this account has now already been checked and it's saved and it's a vote program account. So they might end up not doing further checks in other instructions. And other instructions might do something, I don't know, something very interesting. And yeah, it really depends on the further context. But yeah, for this example, I think that people already have the correct idea. So basically, this instruction can DOS, can be denial of service. Do you know why? Because out of TU, I don't know what's TU. Maybe you mean CU, compute units, but that would not be quite right. Okay, so no takers. So compute units on Solana are not like this can be a problem that it runs out of CU, but what we can do always is to add instruction that increases the CU limit for the transaction, and then we can have like 1 million CU available, and that covers a lot of cases. But in this case, the problem is the heap. So we have a lot of heap allocations. For example, we're working with vectors and have a lot of clones in here and all this kind of stuff. And like a double for loop, which is never good. And yeah, whenever you have like a lot of these variable length types that are used and like used a lot, then you should think about like the heap, because the heap on Solana is relatively limited. It's not infinite in size. And if a lot of stuff happens on the leak, it can be exhausted and the program runs out of heap space and denial of sources. So the attack here would be that because yeah, for 2 tokens we would have 4 or more allocations, because in this case it's quadratic with the 2 for loops and so on. So if you have like 10 positions, maybe you'll have 100 or more allocs. And if you have 100 positions, you'll have 10,000. and you can quickly run out of heap space. Because the Solana heap is quite small, it might happen that a denial of service happens, and yeah, the user can't get liquidated. I see someone actually did write tweet. I didn't scroll down to it, but yeah, that's the basic idea. But I think this bug is relatively known. Also, like it happens on other blockchains as well. It's not that Solana specific, but I think it's a very good category of issues that you should be aware of. Okay, so next issue. Here we have like a maker-taker type order system. So users can create an order, a standing order, that would be a maker, and then anyone can take that order. For example, I can make an order of like, I want to buy 10 SOL for $1,500 USDC, and I can create an account that encapsulates that order, and then anyone can go ahead and take order. I want to take that order, and they will then send 10 SOL and receive those 1,500 USDC, and they will be the taker. And you can delete your order again if no one's taking it. Maybe market changed and you're like, okay, I don't want to buy 1,500, I want to buy 1,400 now. So you can delete it and then create a new order. Yeah, that's it. Okay, no ideas? Mm-hmm. So yeah, one of the big issues here is that the taker does not have slippage protection. And it wouldn't necessarily be an issue if, like, do you have an idea how this can be exploited? Front running, but how? So the taker sends an order to take one specific other order. It's not an AMM. It's more like an OTC. Right. So I'll explain it. So yeah, the problem is basically related to front running and slippage protection. But the tricky part here is that the maker, exactly, they can delete and recreate the order before someone takes it. So there is not necessarily slippage protection needed, because a taker is like, hey, I want to take this order for 1,500 USDC for 10 Sol. This is the order I want. So order ID 15. And if order ID 15 is 1,500 USDC for 10 Sol, they don't really need slippage protection because the order is fixed. But the order can be updated in place by, again, deleting the order and recreating at the same address the order. So if someone sends a take request for this order, and then while this take request is traveling to the leader of the blockchain, the maker could delete their order, recreate it with like, hey, I'm selling or I'm buying 10 Sol now for $1. And now the taker will only receive $1 for their 10 Sol. This could be fixed either by having slippage protection. It could also be fixed by having not being able to delete orders and recreate at the same address. Yeah, I think those two would be the main ways to fix this. It's kind of a bait and switch kind of approach. So yeah, order A, someone is like, I'm buying one Sol for $300. Taker is like, okay, I'm gonna take that order. And then the maker sends a transaction to delete the order and create a new order. And the taker order lands at now it's like buying one Sol for $1. And for this, for example, there doesn't have to be a mempool that the maker can see. They can just create their order, like for a fair price, Solana for $150, and then like randomly send this update and just expecting, hoping for someone to have sent their request. And if no one took it, then they can update it again to the original price and wait again, and then like just go back and forth basically until at some point someone accidentally sends an order for that. And the worst that can happen is that they buy or sell Sol for the current market price. Well, the best thing that happen is they buy or sell it for a very low or high price. So it would be a very good strategy for them. All right, so the next issue here, yeah, there are some more unintentional issues that I annotated, but this is like an NFT marketplace that tries to pay royalty fees to the NFT creator. And basically you can buy an NFT, and whenever you buy an NFT, we somewhere check that's who's the NFT creator. Just imagine there's a check that the NFT creator address is the correct one. And we transfer like 5%. Don't worry about the rounding, that's not the intended issue. That we transfer 5% to the NFT creator, and don't worry about the incorrect transfer because this should be a system transfer because we don't own the buyer account. But still, there's one very sneaky bug in here. Yeah, that's not an intended issue. Depends. yeah, this example is really badly written. No, it will not overflow. Also no spoofing. All right, I'll explain the issue. The issue is very simple. It's this system account here. Basically, we require that the NFT creator belongs to the system program. And if at any time in the future the NFT creator reassigns their account to a different program, then it will not be a system account anymore. And they can do it at any time they want. And that will basically deny of service any transfers for that NFT collection for on that marketplace. And basically the idea of this class is over-constraining. Often this happens with the system account constraint. So we can't be sure that an account stays a system account forever. This is also common, for example, in like referral programs or something like that. That like some account that belongs to someone, that we put a constraint on that they could invalidate if they want to. So, and then this instruction will never work again. When I last gave this presentation, there was another bug, which is requiring that this account has to be mutable, which is kind of obvious that this has to be the case, that it has to be mutable. But unfortunately, at the time, you could deploy a program at the address of an account, and then it couldn't be passed as mutable anymore. And then an instruction would fail. However, this was updated to SIMD in the past couple months, and now you can transfer funds to programs. Yeah, so that's not an issue anymore. So if you learned about that issue last time, yeah, this has changed. But yeah, the takeaway here is basically whenever you see a constraint, you shouldn't just think about how you could bypass this constraint, but you could also think about how this constraint could accidentally prevent a valid transaction from going through because someone could intentionally invalidate that constraint. For example, changing account type from system account to a token account or something like that. Right. So the last bug on our list here is like a payment program. And basically it's take the fee and after charging that fee, it does a token transfer for whatever reason. That's kind of it. So summarize CPI, don't know about changing balance. Can you explain that? Like, what does it mean? What will happen? Cannot serialize last changes. Not sure what you mean. So, I mean, the idea is correct. CPI don't know, will not know about the balance change. CPI doesn't care about land ports. Like, there's no cost. The network don't know about the changing. Okay, I think you have the right idea, but the explanation isn't quite clear. So it's not the min check. Yeah, so the issue is basically yes, the issue is doing a direct Lamport access. So minus equals protocol fee plus equals protocol fee, and then doing a CPI. And in the CPI, so in the direct access, we access the account's user and the account protocol. And in the CPI, we access the account's user token, protocol token, and user. And user, which is used in the CPI, has a different Lamport balance than it had at the beginning of the transaction of the instruction when the CPI happens. And because of that, the runtime will be confused and show an error, a balance error. So I'll explain it here again. So we have 4 accounts when this transaction starts. Let's say each one of these accounts has 100 Lamports. And the runtime does a balance thumb check. And the total will be 400. And it first charges the fee. So let's say 10 Lamports from A to B, so from user to protocol. And then after that, it does the token transfer. So after the fee charge, we have like here 90, we have 110, 100, 100. But all of those changes happened in the SVM and did not have, like, were not written to chain yet. And what the runtime does on the CPI is it checks the accounts and compares them to the last account state it had. So in the CPI, it will now receive the user TA and protocol TA token accounts, because here it takes user, protocol, and user token, protocol token, and user. So user token, protocol token, and user. And we'll read their Lamports, and it will be 100, 190. And for the last account, it only knows the cached version when the instruction was started. So it assumes it's still 100. And it sums everything up. Now the sum is 390 instead of 400. So it thinks, the runtime will think that 10 Lamports just gone missing, and it's going to throw an error. So what you want to do in this case is you would have to pass an additional account. Namely, you would have to pass the protocol account, even though you don't need it in the CPI transfer. You still have to pass it as an account info. like as a remaining account, basically. Otherwise, it will fail. It's very sneaky, and yeah, happens often when you have these direct line port transfers. Normally, it should be caught in testing, because in this case, the instruction shouldn't just work, like simply shouldn't work. But if the audit target didn't test properly, then this can like slip through and be an issue in the live protocol. Okay, so we have like 5 more minutes. So I want to talk briefly about how to spot some issues like those. And basically, you need to understand how the runtime in Solana works and how the SVM like works in detail, and when it stops working, when it shows errors, and what we can do to like induce those errors, maybe on purpose. So I would generally recommend that you, even though you're like a Solana program auditor, you should also maybe take a look at the validator code that executes programs, and understand exactly how it executes those programs and when this execution can fail due to reasons that are inside the program, like those slam-word balance checks or something like that. Other than that, like there's old concepts in security, like in binary exploitation, like use after free bugs, dangling pointers, that we know like from heap exploitation. And you can think of Solana accounts as like heap objects, and then maybe some of those old attack concepts you could reapply. And I always encourage people to like dive deeper into what a program does. So you should deeply understand every single line of a program you audit, and basically always press go to definition and go to definition and go to definition in your IDE until you know exactly what happens behind the scenes. So if some function is called or some info, don't just assume because of the name of the function that you know what it does, but always go and check that code so you know exactly what happens. And if you just keep doing that and keep understanding everything to the deepest, then you should start finding deep bugs. And yeah, that is some tips to how to get really good at Solana auditing. So first tip is, once you know all the basics, I recommend that you pick like a subtopic. For example, bridges, oracles, perps, lending, AMMs, governance, AMTs, launchpads, like, or something else. And you learn this specific niche in as much detail as you can. And you understand like different implementations, different approaches to building this kind of product. Maybe you write your own version, and you should then try to make a list of the very specific bugs that can happen in this type of protocol. So what kind of bugs can happen for bridge that maybe someone would know about immediately? And once you have that list, you should go and look for these bugs in all kinds of protocols. Another way is to learn how one of these specific products works exactly. So you find one specific bridge and find out how it works in absolute detail. And then look at any program that uses that bridge and if it uses that bridge correctly. And then because you know that bridge so well, you'll be able to find very hidden bugs that are like very specific to the usage of that bridge. So that's one approach. Another approach to get better is to do mock audits with a feedback loop. And for that, you find a public audit report from like some audit company. You make sure that audit report has high or critical findings, but you don't check what those findings are. You just, okay, it has like 2 high criticals. Okay, that's it. You find the repository that the that was audited and has to be open source. And then you check out the commit of when the audit started. And then you like, so basically you're at the stage of that the auditors saw when they started the audit. And then you just do this audit yourself. You don't have to do it for 2 weeks. You can do it for like 3 days and see whatever you can find, and then write everything up. And you write proof of concepts and everything. And then at the end, you can compare what you found to the audit report. Now you can check the findings and see if you found things that they missed, or if they maybe missed, if they found stuff that you missed, and then you can fill your gaps. This way you have a quick feedback loop compared to other ways of auditing. The problem here is, a lot of code bases are closed. So it's a bit difficult sometimes to find these kinds of repositories where you can do this. But there are some that are open source and where you can do it. So maybe the approach is to find an open source code base first, and then look at the audits, find an audit for that open source repository that has findings, and then check out that commit. So like go backwards from open source audits, repositories. And then the last thing is to learn new bug classes by reading audit reports and also reading SIMDs in Solana, because a lot of things change in Solana constantly. So bugs that existed half a year ago might not exist anymore, or new bug classes might exist. And you should always keep up to date. And same goes for like updates to like Pinocchio or Anchor. So you should know what changes there, and you should learn what other chains, what auditors find out on other chains. Sometimes those things apply to Solana as well. And always talk to other auditors and talk to other people. And good idea is also, even if you think of yourself just as an auditor, to try to develop a program yourself, and you learn a lot this way too. And that's kind of it. I think, if you have questions, I'm not sure how much time I have here in this room in the co-working space, because in theory my time is over, but maybe you can still have like 2 minutes to ask some questions now. Do Solana programs have as much room for vulnerabilities as EVM does? I think EVM lends itself especially often to creating bugs. So I think it might have more bugs in EVM because it has a lot of silly, like stupid footguns. And in Solana, a bit less, but there are still a lot of bugs in Solana. So it's I think it's less for sure, but doesn't mean there's no that you'll struggle harder to find bugs. I think you can still find a lot of bugs. How can we learn the runtime deeply? So I think the best is just to go to ANSA or R0bre repository and read the source code for the runtime. So you should read the source code for the upgradable loader and for BPF, and basically the validator code that creates the VM and instantiates the VM and calls the program basically, and what happens when your program finishes. And then I can recommend there was a blog post recently by Ichigo. I think he posted it also in the Slack. So you should read that. ANSA has a great blog Here you should read this blog in particular. This one here. And there's a blog post about accounts TP as well. And yeah, I mean, they have a lot of interesting blog posts in there, so I'll just read those. Is it okay to deliver AI written POCs? It is okay to write AI written POCs if they work. If your POC actually works and exploits the bug that you like, if you write a test case, for example, then it's fine if AI wrote it for you. It doesn't matter. But you should understand what's happening there. And maybe it's not the best to write your POCs with AI if you're learning. If you're learning, it's always best to do it yourself. And then if you know how it works, then you can use AI to make it quicker. But yeah, I mean, that doesn't really matter so much. The market competition for SVM audits, demand is pretty high. I mean, we're booked out for 2 months, and if you know what you're doing, then it's pretty good. But the problem is, you have to be pretty good, and it's kind of difficult. It's kind of difficult to go from like a new to pretty good and prove it. What Solana protocols, in your opinion, integrated most, like R0bre, Uniswap, Pendle, etc.? I think integrated the most are gonna be the big lending protocols, like Camino, Drift, MarginFi, maybe Wormhole as a bridge, and oracles like Switchboard, PIF. Yeah, I mean, that's a good list, I think. How should a beginner build a security portfolio? I think you should try to do contests, and try to get good placements. You should maybe write a program, but make sure it's good, doesn't have bugs. You should write write-ups, not with AI, but manually written write-ups about interesting bugs and concepts in the SVM, and try to, like, advanced topics is always good. Like, there's so much content always about like beginner topics, but if you can find some advanced topics and dive deep on them and write interesting content about them, that's always a very good signal in a portfolio. Which framework do you use to write your POC? Normally, I would just write my POCs in the test library that the client or the program that you're auditing already has. So often they have like tests in TypeScript or Rust or Mollusk or Light SVM, like whatever. And normally I would, or even just a mod test, and I would just copy paste one test from them and then modify it and add my, like, so I don't really care. However, if I would do it from scratch, I would use like SVM in Rust. Yeah, I think that's the nicest in my opinion. How often contests for? I don't know. Not that often, honestly. Unfortunately, not many contests. You're learning SVM audits as something. I think you can, like, if I was starting now with auditing at all, I wouldn't do just Ethereum, for example, and I would probably pick like Solana or Move or like hyper liquid. It's just important that you find something where you can be an expert inside and where there's not too much competition yet. But if you're really good, then it doesn't matter. If you're really, really good with auditing and you're a big talent, then you can go to EVM, even like where there's hundreds of auditors, thousands of auditors already, and still be fine. I think, and if you want to become really good, it's most important that you're interested in it. So I was interested in Solana, so for me it was easy to spend a lot of time on it. So I think it's the best approach is to find like what is interesting to you. If you like to work with Rust or with Move, then maybe pick Rust like Solana, or if you like Move, then maybe you should do Move audits, because if it's more fun to you, then it's gonna be much better. Choose a Solana AMM to deeply understand. I mean, just, yeah, I would just learn Radium and Meteora. Those two. I think that's it. I'm gonna finish the call. Then here's my my handles. And yeah, thanks for the questions. I think you did quite well with spotting some of these issues. So yeah. Right. Okay. Yeah. You can also just DM me on Twitter, on Telegram if you have like questions. I check the rect off Slack from time to time, not every day. So if you send me a question there, just give me some time to answer. And yeah, that's it.
Thanks again, Robert. Thanks.